Very good morning to everyone. In this lecture, EC 8791 Embedded and Real Time Systems. In this lecture, we are going to discuss the real time embedded system. It is a unit 4 in Electronics and Communication Engineering department. Today topic, it is a estimating program run times. So it is one of the real time operations such as real-time operations. It is a operating system. The time interval required to process and respond to the input is very small. It is a time level interrupt interval, that is a time interval. It is called response time. So here the estimating program runtimes, the real-time system meet deadline. It is important to able to accurately estimate the program runtimes, and the estimating the executing time of any given program is a very difficult task. It depends on the following factors. First one is a source code and a compiler and a machine architecture and also the operating system. The source code, we have to analyze the requirements of the design in software and hardware level, and also the compiler, how to mapping it should be depend on the compiler used. So for example, we are using the model sim, we are using the tanner, we are using the different kind of compiling tools in different hardware equipments. And then machine architecture, how to support the co-processor in our primary processing units, CPU. And also the operating systems. So different kinds of operating system, different levels of operating system we are needed to execute the program. Now we can see it analysis of source code first of all. So we have to see the label. It is a address label. So L1, it is one of the L1 is a address label. The address label A is equal to B into C. That is a B and C. It is a multiplication operation to execute the A operation, A file. So the label 1, it is a executed functions file. It execute the A is equal to B multiplication of C. The same for label 2, B is equal to D addition of E, and label 3, D is equal to A subtraction of F. It is a summation of the execution time. It is a length of the sequence in the specific time period. So the label 1.1, it's a matrix. It let address of C and load the C and get the address of B and load the B, multiply and store into the A. So these are the set of instructions, and we have to set up the protocols. So in label 5, we have to understand the label 5 or label 4 or label 6 or label 7 or label 8. So the Q condition in first out modules. So we have to implement the different data. We have to implement the different modules. In each module is specified the output of the another module's input. So we have to execute the one by one. It's a queue model. It's a subtract, that is a stack method. So here the execution time, that is a, we have to see the label 9. In label 9 operation, if B1, then S1 is equal to T of B1 plus T of S1 plus T of jump. So the label 9 is a condition of the B1 is a S1 is nothing but the data. is addition of the data in the true. The execution time is executed the b1 and s1 or jump. So if else conditions b2, so the s2 is nothing but the same operation. It can be the double of the execution time period. So next condition, if else b3, then s3 is equal to nil point, so execute the s4 is, it is a continuous of loop statement. So whatever may be, we have to function the entire modules. It is a one by one, we can put the conditional statements. So we have to execute the program in one by one in stack method model. It is a runtime quick errors. Next one, it is a schematic of timing estimation system. The time estimation depends upon the processor and also the software coding. So here with the preprocessor, the preprocessor is interface with the processor and they produce the time and produce the loop bound to different time schemes and different coding predictions and architecture analysis. So this set of estimation we have to finalize the end of the execution in the quick runtime, that is real time operations. And we have to see the accounting of pipeline method. It is one of the two stage pipeline method. First one is the instruction fetch stage and execution stage. So the instruction fetch stage is opcode generate to communicate with the execution stage and handshaking signals. It can be accumulated to the memory port or memory. So the T1 is a function of the set of optimized coding techniques B1, BI plus 1, BI plus 2, where the B1 and B2.1 and B2.1 applies the move from the memory port in the memory location. So here we are using the memory port and memory location. We are following the two set of memory. One is a cache memory, another one is a virtual memory. So this is a functional structure of the how to estimate the program runtime. In upcoming sessions, we are going to discuss the task assignment and how to schedule the algorithms. Thank you for watching this video.